Now the factor formula. These are what we call factor formula. Sin A plus B plus sin A minus B is this. And how did you get this? We recall from the compound angles which I have given before. If I decide to add these two together, you know that this will leave. This minus this will be 0. What we are going to have left is this plus this, and it will be sin A, 2 sin A cos B. The same thing, if I decide to subtract, this will leave. It will remain 2 cos A cos sin B. That is it here. So we can do the same thing for cos by adding these two together and by subtracting. We are going to get these 4 formulas again, which we call factor formulas. Also, if I decide to say that let A plus B be equal to P, and let A minus B be equal to Q, you will see that A will be equal to P plus Q over 2 after solving the simultaneous equation, and we will see that B is equal to P minus Q over 2. In that case, this factor formula will now become what we call addition formula. The first one there too will become sin P plus sin Q, because we have said let this be P, let this be Q. So anywhere I see A plus B, I'll write it as P. Anywhere I see A minus B, I'll write it as Q. And my A will be represented by P plus Q over 2, while my B will be represented by P minus Q over 2. In that case, these 4 formulas will change to another form. So we are going to have this. So I've changed all the A plus B to be P, all the A minus B to be Q. So we have another formula which we call addition formulae. So we can summarize the results as follows. So this is a summary. Sin A plus B plus sin A minus B gives this. It's summary once again. Now let's take example on how to use this formula. Look at this example. Expressed as a product of 2 trigonometric functions, sin 4s plus sin 8s, cos 4s minus cos 3s. When we are adding 2 sine together, or when we are subtracting, or cos, that is when we apply addition formula. Now, I only need to recall that for this, I only need to recall that sin P plus sin Q is equal to, so if I recall this formula, then I will take this to be my P, 8s to be my Q. So in that case, I cannot have that sin 4s plus sin 8x will now become 2 sin P plus Q. Our P is 4s, our Q is 8s. That is 4s plus 8s over 2 cos 4s minus 8s over 2. And that will give me 2 sin 4s plus 8s, that is 12s divided by 2, that will become 6x. Also cos 4s minus 8s, that is minus 4s, divided by 2, that will become minus 2s. But in trig, minus does not affect cos. Minus will only affect sine and tan. In that case, my answer is still 2 sin 6s cos 2s. So the minus will not affect it. Cos minus 2s is same thing as cos 2s. If you look at the second one, which is cos 7s minus cos 3x, I will need to recall the one for cos P minus cos Q, and that will be, I recall this formula, then our P is 7s, our Q is 3s. Therefore, our cos 7s minus cos 3s will now be equal to minus 2 sin P plus Q, 7s plus 3x over 2 sine 7s minus 3s over 2. Finally, our answer is minus 2 sine 7s plus 3s is 10s divided by 2, 5x sine 7s minus 3 is 4s divided by 2, that is 2s. So that means we have expressed as a product of two trigonometric functions. Another example on this, express the following as a sum of two trigonometric functions. You can see that it's in product. We now want to express in terms of sum, in terms of plus or minus. That is the meaning of sum here. Now, we need to use the factor formula, the first set, in order to solve this. That is, we make use of this first four, any of it. Now, to solve the first one is involving sine before cos. That means I'm using this one that has this sine before cos. So I'm going to make sine A cos B the zero formula, so that it's having this sine is coming before cos because of the equation. So in that case, we are going to have, so we have this. If you make sine A cos B the zero formula, so that it looks like this. So in that case, I can say that my A is 4x and my B is 8x. So in that case, sine 4x cos 8x will now be half into I will represent A by 4 and B by 8x, so that we have this. But 4x plus 8x is 12x. 4x minus 8x is minus 4x. But I told you minus will affect sign. So since minus will affect sign, the minus will make this plus to be minus. So that our answer will finally become sine 12x minus sine 4x. So that is the final answer to this. If I consider another example, cos 3x cos 4x. So I'm looking for the one that is having cos and cos beside it out of these first four. So the one that is having cos and cos beside this is this, cos A cos B. So I'll just make cos A cos B the square formula, and I'm going to have, we will call this, in this case, our A is 3s and our B is 4s. So our answer will just become half into, anywhere we see A, we put it as 3s. So that will be cos 3s plus 4s plus cos 3s minus 4s. And that will give me half into cos 7x plus cos minus x. But this minus will not affect cos. Our final answer will become 1 over 2 cos 7s plus cos s, because the minus will not affect the cos. So cos minus s will still be the same thing as cos s. Now let's move to another question. So you can practice the remaining two on your own. You just check the one that has sine and sine, cos and cos before sine. Then use it to solve the remaining two. Now let's move to another example. Let's prove that this is equal to this. I'm going to use the addition and factor formula. We'll be adding sine and sine, cos and cos. So which formula are we going to use? So we are going to use these two formulas, sine A plus B and cos P plus Q. We are going to use that. And okay, let me quickly write it. Now I will record the one for sine P plus sine Q. But you see that we have minus here. The question you should ask is, why don't you use sine P minus sine Q? Anytime we are using this, P and Q must be of the same nature. That is, if they are odd, they must be odd. Both of them must be odd, or both of them must be even. If you can see that A and 2A, 2 is even, while A, or 1 is odd. But if you pick A and 3, they are both odds. So these are the two that can only merge. I will use this formula. These two I'll use this so that I will have this plus this, cos A plus cos 3A. I will record this formula. In this case now, I've rearranged by saying sine A plus sine 3A, this is it, minus sine 2A, the same thing to the denominator. Now, this is our P, this is our Q, this is our P, this is our Q. If I use these two formulas for these two, I'm going to have this. But noting that there's minus sine 2A here, minus cos, these two have given me this, and these two have given me this, using these two formulas. From that place, I'm going to have 2, if I simplify, A plus this, that will give me 4A, divided by 2, that will be sine 2A. Then cos A minus 3A is minus 2. Minus 2 divided by 2 is minus A. Then minus will not affect it. I'll just write A like that. Minus sine 2A divided by 2 cos, the same thing, they are the same thing. It will be 2 cos 2A, cos A as well, minus cos 2A. You now observe that from the numerator, sine 2A is common. So let me bring it out. If I bring it out, if I factorize, I'm going to have 2 cos A minus 1 over, this one will become cos 2A. If I bring it out, cos 2A is common too. It will be 2 cos A minus 1. From that place, you observe that this will cancel each other. What we are going to have left is sine 2A over cos 2A. But sine over cos is tan. So sine 2A over cos 2A will now become tan 2A. So that is proved. That is what they asked us to prove here. So we have proved it. Let's take another example. This is another example. Show that this one is equal to this. You observe that the other time I said odd will go to odd, even will go to even. But this one is controversial somehow because all of them are odd. Then the question is, which one can we merge together before we can use the formula? Which one can we merge together? Now, when it happens like this, look for pairs. If you consider this 7 and this is 1, 7 and 1 will give me 8. 5 and 3 will also give me 8. Definitely I have to use 7 and 1. So that is the trick we are using so that I can rearrange this thing as sine 7s. I will arrange it like this. I brought this minus here and this is plus cos together. But this one, minus, I can put it in bracket. If I put it in bracket, this plus will become minus. So that if I expand the bracket, it will become plus. Likewise, this is minus cos 3. If I put these two in bracket, that minus cos 3 will become plus cos 3. Then I'll use the formula for sine A minus sine P minus sine Q. Sine P minus sine Q. This one too, cos P plus cos Q, cos P plus cos Q. Let me bring it again. I will not need to write it again. So this is it once again. You can pause it and write it out and use it to compare so that this expression here, if I use the formula, it will become. So when I use the formula, I'm going to have these two. So you can check the formula and cross-check. From this place, if I simplify further, let me simplify this further so that we are going to have, if I simplify further, I'm going to have this 7s plus s is 8s divided by 2, which is 4s. Sine 7s minus s, that is 6 divided by 2, 3s. So we are going to have this. So you will now observe that 2 cos 4s is common to this, common to this, common to this, common to this. So since it's common, I can cancel it out. So that I'm going to have sine 3s minus sine x. Since it's common, I'll cancel it out. We are going to have cos 3s minus, this one is cos, not sine, minus cos x. So it leads to another formula again, which is representing sine P minus sine Q, cos P minus cos Q. So I'm going to use that again. This is sine P minus sine Q. I'll use this formula, pause it and write it out. Cos P minus cos Q. So So we are going to get this when we use the formula. So you now observe that this is gone, is common, 2 is common. What we are going to have left is minus cos, this is 4 divided by 2, that is 2, minus cos 2x over, this one is sine 2s. So, and we know that, we know the formula, I've given you the formula for this. We know that cos 2 is same thing as cos square s minus sine square s, which we have done under compound angle. Also sine 2s, we know that is same thing as 2 sine s cos x. From this place, this 2 is constant. I can bring it out. So if I bring it out, I'm going to have 1 over 2 into, there's minus here too. This minus will affect this plus, this cos. The cos will become minus, and the minus will affect this. It will become plus, so that I'm going to have sine square s divided by sine s cos s minus, this one too will be cos square s. I've divided this sine s cos s by these two separately. Sine s cos s once again. What are we going to have? Sine s cos s is cancelled. What we have left is sine s over cos s minus cos s is also cancelled. We have cos s over sine s. Finally, our answer here is sine over cos is tan x minus cos over sine is cot x. So that is what they asked us to prove here. Half into tan s minus cot s. And we have finally proved it. Let's move to another example. This textbook, this is another example. We want to show that cos 2 into a plus b plus cos 2a plus cos 2b plus 1 is equal to this. And this is a solution here. You can see, because of these two, I say recall that cos 2 theta is equal to 2 cos square theta minus 1. For instance, for the person that asked me about which one are we going to use, you see that we are dealing with cos all through. So I used 2 cos square theta minus 1 instead of the other ones. Now, instead of this cos 2ab, I'll take this a plus b as my theta. So that our answer will now become, okay, it's even here. Therefore, our cos 2ab is representing my theta. It will now be 2 cos square ab minus 1. So I'm going to do that for this one and this one. This is it. 2 cos square ab minus 1 plus cos 2a. This is it. We only changed these two. We did not touch the rest. From this place, you observe that minus 1 plus 1 is gone. Minus 1 plus 1 is gone too. Now, I will now use the formula for cos p here. Cos p plus cos q. I'll use the formula, and that is it. I'll use the formula. You can pause it again. I'll use the formula. When I use the formula, it will give me 2 cos p plus q over 2 cos p minus q over 2. Likewise, this denominator, I'm going to have it. If I simplify, 2 will cancel this 2 here. It will remain a plus b. This one too will remain a minus b, as we have it here. Now, from this place, you now observe that cos a plus b is common. Since 2 cos a plus b is common, we can see. So when we factorize, we are going to have this. Cos a plus b is cancelled. Then what do you have left? I will now use the formula for cos a plus b, cos a minus b. That is the factor formula. I'll use it. This one. We know that cos a plus b, cos a minus b is 2 cos a cos b. And this one too is, when it is minus, I have minus 2 sine a sine b. So that is what we are now using here. When I've cancelled this out, we have this thing left. Cos a plus b is 2 cos a this. And this one gives me this. From that, this 2 is cancelled. What we have left is cos a over sine a, which is minus cot a. Cos b over sine b is cot b. So we have proved it. We have proved that this is equal to this. Now let's take another example. Another example, if A, B, C are angles of a triangle, show that sine this plus sine this plus sine this is equal to this. Now, as usual, we know that if A, B, C are angles of a triangle, A plus B will be equal to 180 degrees. Or we say that A plus B is equal to 180 minus C, or vice versa. I can say that BA is equal to 180 minus BC. It's still this B plus C, still the same thing. Now, we also recall that sine 2 theta is equal to 2 sine theta cos theta. Now let us now come here. What they asked me to prove here, let's come there. Therefore, sine 2a plus sine 2b plus sine 2c will be equal to, I will apply the formula for sine p plus sine q here. I can apply it to the third one. Sine p plus sine q will give me 2 sine p plus q, p plus q over 2 cos p, our p is 2a minus q over 2 plus our sine c is 2 sine c cos c. From this place, you observe that a plus b is gone and 2 is common. I can cancel out so that we are going to have sine a plus b. Likewise, 2 is common, so I can cancel it out. We have cos a minus b plus 2 sine c cos c. But from this place, 180 a plus b is equal to 180 minus c. So this will now become 2 sine 180 minus c, that is a plus b, cos a minus b plus 2 sine c cos c. But let's take note that sine 180 minus c is equal to, if I use compound angle here, it will be sine 180 cos c minus cos 180 sine c. But sine 180 is 0, vanishes this one. But cos 180 is minus 1, so it will make this minus to be plus. So our answer is still sine c. What we are saying is that sine 180 minus c is same thing as sine c. In that case, our expression continues. It will become 2 sine c, this one. Then cos a minus b plus 2 sine c cos c. You now observe that 2 sine c is common. This will be 2 sine c is common. What we have left is cos a minus b plus, you know that 2 sine c is common. I have brought it out. It will remain cos c. So this will be cos, our c is from this place. If you make c the zero formula, it will be 180 minus a plus b. So let's say I have cos c there. Here we have 2 sine c cos a minus b plus cos, this is 180 minus a plus b. That is that about this. Our c has turned to 180 minus a plus b. But what is cos 180 minus a plus b? It will be cos this minus sine this. So in that case, cos 180 is minus. So this one will give me 2 sine c. You can do that on your own. Will give me minus cos a plus b. If you apply compound angles, cos 180 cos these two. But cos 180 is minus 1. That is why we have minus cos these two. The other one side will be sine 180, and sine 180 is 0. So we now use our formula here. Our formula is cos a plus b is cos a minus b is equal to minus 2 sine a sine b. You see that we have the same thing here. As you can see that we have the same thing, but it has been interchanged. Plus is coming first, a plus b is coming first, a in this place, but here a minus b is coming first. But as we have minus 2 sine a b here, and it has been interchanged, it will just be 2 sine a sine b. So that our answer is 2 sine c into the whole of this will now become 2 sine a sine b. If you expand, finally, you see that 2 times 2 is 4 sine a sine b sine c. So that is what they asked us to prove, and we have proved it successfully. Let's consider another example. It is you that I want to study very well. I want you to study this very well. It is you that I want to study very well. Now, look at the question. So this is the question here. If A, B, C are angles of a triangle, prove the following. This is the question. I have solved this one. So this is the solution. You are going to solve it on your own. It's an assignment, but at least I'm giving you solution here. This is solution. This is solution. And this textbook is the recommended textbook. This is the title. It's the recommended textbook for this course. And this is my name here. So when we resume, I will introduce it to you so that you can get your own copy. Another important question. Express this in terms of in terms of r cos s minus theta. Hence, find theta and solve for s if this is equal to 1. We want to solve this equation. Now, the first thing is that I'll first need to express this thing in terms of r into s minus theta. Now, I'll just write it as this. Our aim is to find what is our r and what is our theta. Then I'll use the formula of compound angle, which says cos a minus b. So our answer is cos s cos theta. From the compound angle, this will be plus sin s sin theta. So if you compare to the above, this is our cos s. The coefficient of cos s here is r cos theta, and that will be square root of 3. Also, if you compare this side, our coefficient of x here is 1. So that means r sin theta is equal to 1. From that place, if you divide both sides if you divide this by this, we are going to have r sin theta over r cos theta is equal to 1 over root 3. R cancel r. What we have left is tan theta, because sin theta over cos theta is tan theta, equal to 1 over root 3. So if you make theta the same formula here, theta will now become arctan 1 over root 3. And arctan 1 over root 3 from calculator is 30 degrees. I have found the value of theta, what they asked us to find. Now let me know the value of r. Here we said r sin theta is equal to 1, which means our theta is 30, which you have known is equal to 1. Therefore, our r is equal to 1 over sin 30. And 1 over sin 30 is 2. So you can check that on your calculator. So we have known our r, we have known our theta. So what we are now saying is that root 3 cos s plus sin x is equal to, we have said is equal to r cos s minus theta. That is 2 cos x minus our theta is 30 degrees. So we have done that. What we have to do here, we have done that. Now the question now says we should solve this question here. Root 3 plus s is equal to 1. So I can now say that root 3 cos s plus sin s is equal to 1 implies that, here has been 2 cos s minus 30 degree equal to 1. If you make cos s minus 30 degree the same formula, we are going to have 1 over 2. Then this has led to what we are doing under quadrant of angle. S minus 30 is arc cos half. But arc cos half from calculator will give me 60 degree. But that is not the only answer. Also, I'll look for where cos is positive. That is the third quadrant. That place will be 360 minus theta. So in that case, I cannot say that my s minus 30 is equal to 60, or s minus 30 is equal to 300. From that place, s will be equal to 90 degree, or s is equal to 330 degree. So in that case, the solution to the question will be 90 degree and 330 degree. So that solves the question. Now let's take another example on this. This is another example on that question. Now we have to express this thing in terms of r sine theta minus a. Find r and a. Find the minimum and maximum value of this expression and solve the same expression equal to root 3 over 2. Now I'll start by equating the question equal to r sine theta minus a. Then I will apply compound angle here, the one that has sine a minus b. This will be sine theta cos a minus cos theta sin a. Now after that, I will compare both sides. The value of coefficient of sin theta here is r cos a, and that one here is 2. Also, the one for cos theta is r here, and the one for cos theta is 1. So from that place, is 1 sin a. There is sin a is 1 sin a. So in that case, I can divide this by this, so that I will have sin a over cos a is equal to 1 over root 2. Therefore, my tan a is equal to 1 over root 2. Then we look for a from our calculator. A will be equal to, and from our calculator we are going to have 35.26. So we have known our a. How can we know our r? So we can do it in two ways. You can substitute the value of a here and get our r, or we square both sides. If we square both sides of this, we are going to have r cos square a is equal to 2. If I square this one, r square will be equal to sin square a. If you add it together, because I know that if I add it together, okay, this one is r sin a is equal to 1. So that is what we have in that place. So r square sin square a will be equal to 1. So, and in that case, we are going to have, if you add it together, you will see that cos square plus sin square is 1. So that we have r into cos square a plus sin square a is equal to 2 plus 1. This one is 1 already. In that case, r square is equal to 1 plus 2, which is 3. Therefore, our r is equal to square root of 3. So we have known our r. So the first one says I should find r and theta. R is root 3. Our theta is arc tan 1 over root 2, or 35.26. So in that case, I can now write the expression, which is root 2 sine theta minus cos theta is equal to, we said it should be in form of r sine theta minus a. So that our r is root 3 sine theta minus our a is 35.26. So we have done that. Now the second one says I should find the minimum and maximum. Anytime they ask you to find the minimum and maximum of this type of expression, you know the value of r. The value of r matters. So you cannot conclude, for the second one, you cannot conclude that minimum value is minus r, which is minus root 3. Maximum value is ordinary r, which is root 3. So the r we get here, we give you minimum and maximum. So our minimum is minus the negative of it, while our maximum is the positive of it, which is root 3. So we cannot proceed to solve this one. We want to solve this, but what we have for this expression is root 3 sine theta minus 35.26. So it will be equal to root 3 over 2. You see that root 3 cancels root 3. What we are going to have left is sine theta minus 35.26 is equal to half. So from this place, our theta minus 35.26 will be equal to arc sine half. From calculator, our arc sine half is 30 degrees, but it's not over there. We use the quadrant angle. So where theta is positive, where sine is positive, so that our answer is 35.26 is equal to 30, or theta minus 35.26 is equal to, that will be the second quadrant. What we have there is 180 minus theta, 180 minus 30, which is 150. If I solve for theta here, our theta is 30 plus 35.26, and the second one here, this is 150 plus 35.26. So this will give me 65.26, or theta is equal to 185.26. So that will be the final answer. And generally, if you are given an equation of this form, a cos theta plus b sin theta, to be expressed in terms of this one, or they are negative, that is theta minus cos a, r will always be square root of a square plus b square here, that is square root of their coefficients. The minimum will now be minus r, and the maximum will now be r. So our a sometimes can be arctan, while sometimes can be arc cut, depends on what we are given.